terms of this beer bottle that I talked about to you earlier. So that's a video. You can watch that. But this theory of inflation, which actually says our universe, the qualities that we see of our universe can best be explained if some early time in the history of the universe, when it was a billionth of a billionth of a billionth of a billionth of a second old, it had a huge expansion suddenly and increased in size by 30 orders of magnitude in size in a billionth of a billionth of a billionth of a billionth of a second, which is, by the way, particle physics suggests is highly plausible, even though, okay? And then it would produce a universe that looks more or less like we look like. And it's right now the only explanation of how that would cause the universe to look like what it looks like. But the neat thing about inflation is it's eternal. So inflation, that puffing up ended in our universe, and then boom, a hot big bang followed it. Okay, so the universe puffed up by a huge amount, then all of that energy, which was stored in empty space, got released, like in the beer bottle, and we got a hot big bang, and the rest is history. But that's locally. But somewhere else, between us and there, space is still expanding exponentially, and faster and faster and faster, and only maybe somewhere else today, boom, like an ice crystal forming, boom, that region of space is suddenly left inflation. And maybe a gazillion years in the future, there'll be another region of space that's expanding away from us so much faster than light, so we'll never know about it, where suddenly that region leaves inflation, and boom, another hot big bang happens. And it turns out in each of those hot big bangs, after the inflation ends, depending upon how it ends, the laws of physics could be different in that universe. And so we tend to think it's quite likely that there are many, many separate regions of space, and in fact it's eternal. So such regions are forming eternally for all time. And there are hot big bangs happening in many regions. And the properties of each of those regions, whether they're conducive to forming galaxies and stars and planets and people, may be different. So we could say, logically in that picture, that the reason the universe looks like the way it does is because we're here to measure it.
Oh my God, we should leave it at that.
Okay.
We should close with that. That is the mind blower.